Hi there. Today we're going to talk about introduction to proofs. And so a proof is a logical explanation to show something is true, okay? And some people, I like to think of it as the how and why that something works, okay? So let's talk about the three kinds of proofs. So the three kinds of proofs are going to be a two-column, a paragraph, and a flowchart proof. The most common that we're going to use in this class is a two-column proof. And so a two-column proof is statements in one column with reasons for that statement in another column. A paragraph proof is a two-column proof in paragraph form. And then we have a flowchart proof. A flowchart proof is a visual display of those statements with their reasons. So let's talk about a couple of properties and then let's jump into some actual proofs. So some of our basic properties that we have in mathematics is the reflexive property, the symmetric property, the transitive property, and the substitution property. The reflexive property shows something is equal to itself. So if I were to say the value 5 is equal to 5, or I would say that length AB is congruent to length AB. Something is equal to itself or congruent to itself. Symmetric means we move across the equal sign. And what I like to say here is like x is equal to 2, then I know that 2 is equal to x. Okay, so it doesn't matter what side those are on as long as they're equal to each other. All right, and I could say for example, like segment AB is congruent to segment CD. All right, but then I could also flip that around and say that CD is congruent to segment AB. All right. The transitive property is a little bit interesting, but we'll talk about that here in a second. Substitution is one that we use a lot, and a lot of people don't understand what it is, but it means to replace something. All right. So for example, if I know that x is equal to 2, and if I know 3x plus 1, I could replace this x with what it's equal to. And I could substitute that x here and end up getting 3 times 2 plus 1, okay? Which would then give me 6 plus 1, which gives me then 7, okay? That's the idea of substitution. The transitive property means this, all right? It's hard for me to explain it in words, but what I like to say is that if A equals B, and B equals C, then A is equal to C. And I like to think of this old Family Guy episode where Peter Griffin says the transitive property. He says, kerosene is fuel, Red Bull is fuel, therefore kerosene is Red Bull. And that's the same idea. If A is equal to B, and B is equal to C, all right, then A would have to be equal to C, all right? And so those are the different properties. And so we're going to use these for our reasons for a lot of these things. So a lot of our proofs, we use our properties to provide the reasons. All right, so now let's jump into some actual proofs so you can see what I'm doing, okay? Okay, on this first example, any proof is like this, okay? Where it says that if you're given these statements, use logic and reasoning to then prove that this statement is true, okay? So the first thing I want to do is talk about this. It says that segment AB is congruent to CD and segment EF is congruent to CD. Prove, so use this information to then prove that AB is congruent to EF. So the first thing I like to do is actually just draw a picture, all right? So I'm going to draw length AB, all right? And we're going to just assign that segment length to be 2 inches, all right? So if AB is congruent to CD and I were to draw segment length CD, a congruent piece to that, CD would also be 2 inches. Now, if I know that CD is also congruent to EF, and I wanted to draw EF, based on this picture here, based on this logic, I would then know that EF is also 2 inches, okay? Therefore, AB and EF are congruent, okay? So all I'm doing is just drawing a picture of the situation so that I can logically think about it in my head. Now, the hard part is now putting this on paper into a proof form. Now, proofs are very easy to start, and I'm going to do a 2-column proof. And in this 2-column proof, what I'm going to show is I have a column for my statements and then a column for my reasons, okay? And then I'm going to move down into my logic and end at my proof statement. So my first statement is, and I write number 1, and I write that AB is congruent to CD, okay? And the reason why I can write this statement is simply because it's given to us. Merry Christmas, Happy Hanukkah, Happy New Year, Happy Birthday, whatever it is, but this is a gift, okay, that I'm giving you. Now, the second statement that I can write is my other given statement, that EF is congruent to CD, all right? And the second, and I say that the reason for that is because it's given. You're welcome. That was a gift. All right, so now the question is how do I use this information here to then arrive at this conclusion, okay? The first thing I want to do is I want to switch these around, okay? And say that, well, I could rewrite this statement here saying that CD, whoops, all right, that CD is congruent to EF. And all I did there was the symmetric property. Okay, I just changed those around. All right, so that's the symmetric property. Now what I know is that AB is congruent to CD, CD is congruent to EF, therefore my fourth statement and my final statement is that AB is congruent to EF. And I can make this conclusion and jump from these steps to this step by saying that this is the transitive property. All right? And now that I'm completed this proof, all right, and gone from my given statements down to my prove statement, then I have proven this to be true. Okay? Now let's look at another example. Now on this example, we're given that point C is the midpoint of segment AB. And if AB is equal to 10, then prove that the length of AC is 5. Okay? So real quick, I'm going to draw a picture for this situation. And I'm going to make a segment length AB. Okay? I'm going to put point C in the middle because it's a midpoint. And I know that a midpoint cuts things into 2 congruent parts. So then what I know is that if the whole thing is 10, then we cut these in half and I get 5 and 5, therefore that AC is equal to 5, okay? Now, all I'm doing is taking the given information, drawing a picture, drawing some conclusions based off of the information, based off of what a midpoint is, that a midpoint cuts something in half into 2 congruent parts, and that I can then say that AC is equal to 5. Okay, so at this point, what I want to do is take this logic, put this into a formal proof so that I can prove that this statement is true. Okay? Okay, so when I write out my formal proof, I write out my chart. Okay, I put statements in my left column, reasons in my right column. I first write out my 2 given statements, Merry Christmas, okay, Happy Birthday, those are gifts, and I say that C is a midpoint of AB, and I know that AB is 10. So what I then know, all right, based off of my, this point here, okay, or this statement here, I can draw the conclusion that since C is a midpoint, I can then say in my third statement that AC is congruent to CB. All right? And the reason why I can say that is that's the definition of a midpoint. Okay? A midpoint, remember, cuts something in half or 2 congruent parts. Okay? Now, all right, the next thing that I can say is that in my fourth statement, I could say, well, if I take the length of AC and add it to the length of CB, that's going to give me the whole length AB. And what we learned previously in other sections is that's the segment addition postulate. All right, so segment addition postulate, okay? And now what I want to do is I'm going to do some substitution, okay? And in my fifth statement, I'm going to say that AC plus AC, and I'm doing this because I know that AC is congruent to CB. So because CB exists here, I can insert AC where CB is. The other thing that I can do is I can substitute the value of 10 into AB. So I'm going to come in here and write that that's equal to 10. And the reason why I can do that is because of substitution. All right? Now, the next thing I want to do is I'm going to add these two together. All right? And I'm going to say, well, if I have AC plus AC, all right, all that's going to be is 2 times AC. So 2 times segment length AC is equal to 10. So then in my sixth statement, I'm going to say that the reason why I did that is because I'm combining like terms. All right? And then in the second statement, or the seventh, sorry, I'm going to say, I'm going to divide by 2 on both sides, and I'm going to get that AC is equal to 5. And the reason why I did that is that's the division property of equality. Okay? And then I'm done. Because what I've done is I've used logic and information to arrive from my given statements down to my prove statements. Now this one was a little bit more involved, okay? And this one took a little bit more prior knowledge to be able to do. However, the concept is the same, okay? Now, guys, we're gonna do proofs all year, okay? I'm merely introducing this to you, and it'll be something that we'll work on throughout the year, okay? I'm more concerned about your knowledge of, well, what is a proof, and the different kinds of proofs, and the properties that we learned about, okay? And that's it. So, and my hope is that, guys, you can have this information and come up with this conclusion on your own. Writing this out formally is an expectation. However, it's going to be hard, okay? But I'd rather you be able to think logically to arrive at this answer. And if you can do that, then that's half the battle, okay? So you guys are doing great. I know this was a longer video than typical, but there's just a lot of information in this. So hope you enjoyed this. We'll talk to you soon. Thanks a lot. Bye.